Hello, everyone. This is Mr. Alex Okunda. I'm a professional physics and mathematics teacher. In this lesson, I shall be taking you through calculus and we shall be focusing on differentiation. So, differentiation it is one of the most interesting branch of calculus because we are simply continuing with the O level work where we learned how to find the gradient of a straight line. But in this video, we shall be going deeper and finding the gradient of a curve or simply differentiating a curve. So we shall be introducing ourselves to the general rule for differentiating, and then we also look at how to differentiate a function which has got more than two terms, and then we look at how to find the coordinates of the stationary point and how to find the nature of the stationary point. So uh, when we have y is equals to k x power of n, of course, where x belongs to R, that is where x is a real number. For us to find the derivative of this curve, then we will be using the general rule dy dx is equal to multiply the power by the constant k n, and then once we have multiplied the power by the constant, we subtract 1 from that power, which will be now give us n minus 1. So it doesn't matter how many terms are in a particular function. We differentiate successively each term. So that is the general rule. Let's look at the following example. This question, it has been drawn from the A level, year 12, introduction to calculus. And the question says that the curve C has an equation y is equals to 5x power 4 minus 24x cubed plus 42x squared minus 32x plus 11 where x belongs to R, or x is an element of R. Find dy dx. So we will use the general rule that I have stated above to find that derivative. That is, we are differentiating x, we are differentiating y with respect to x. So we will write there dy dx is equal to multiply the power by the constant. 4 times 5 is 20 x, subtract 1 from the power, that is 4 minus 1, which gives us 3, minus, go to the second term, we have 3 multiplied by 24, which is 72, and then subtract 1 from the power, that is 3 minus 1, which is 2. Then go to the third term, 2 multiplied by 42 gives us 84. And then we subtract 1 from 2, which is 1. So we don't write here 1, just leave it as x. Then we go to the last term, we are differentiating 11. And when we differentiate a constant, we get 0 because the slope, or simply the gradient of a constant, it is 0. So we leave our answer. This is 84x. Okay, I forgot about 32. 1 multiplied by 32, of course, that is 32. We leave it like that. That is the the derivative of that curve. The second part says d squared y dx squared. So what does that imply? Let's go back to our general curve here. So this curve here has got two turning points, this one and that. So in the first turning point, dy dx, it can be treated as this point here, that is the first derivative. And then this is the maximum point, and then this one is the second derivative. So this point is what now I am referring to as d squared y dx squared. This one means it is the second derivative. This is the first derivative, dy dx. So to find the second derivative, you simply differentiate the first derivative following the same technique that I have highlighted here. So how is it going to be? I will write dx d squared y over dx squared is equal to multiply 3 by 20 gives you 60, subtract 1 from 3 gives you 2. Multiply 2 by 72, that one gives you 144. Subtract 1 from 2 just gives you x. X power 1, but you don't write the 1, you just leave it as x. And then power of x here, it is 1. 1 multiplied by 84, it is 84. And then 1 minus 1, it is 0. And as we know, any number raised to the power of 0, it is simply 1. So we don't write here x power 0, just write it as 84. And then you are differentiating 32. When you differentiate a constant, you get 0. So that is our second derivative. Then next, verify that x has a stationary point at x is equals to 1. Verify that C has a stationary point at x is equals to 1. What do we know about stationary point? From our general graph here, this is the stationary point. This is also a stationary point. So the gradient at the stationary point, a stationary point is also called the turning point. Let's not forget about that. So the gradient of the stationary point, it is always equal to 0. So we are going to put where there is 1, where there is x, we are going to put there 1 and see whether dy dx gives us what? 0. So let's see. We have dy dx is equal to 20 multiplied by 1 multiplied by 1 raised to the power of 3. Don't forget that. Then 2 multiplied by 72, which is 144. Okay. Sorry, just backward. Okay. Okay. Yeah, that is 72 into bracket 1 squared plus 84 into bracket 1 minus 32. So from here, we simply now calculate 1 cubed, it is 1. So 1 times 20, it is 20. 1 squared is 1. 1 times 72 is 72. Then 1 times 84, it is 84 minus 32. So because you are verifying, you have to put all the steps there. Don't put 1 in your calculator and then get the final answer. It is good that you show all the steps there. So now at that particular point, you can use your calculator. So we have 20 minus 72 plus 84 minus 32. That one gives us 0. So you don't just leave your answer like that. You have to go ahead and explain. You give the final statement that since dy dx is equals to 0, C has a stationary point as a stationary point at x is equals to 1. That one it will give you full marks. Now, next one, show that this stationary point is a point of inflection, giving reasons for your answer. For our information, is that, sorry, there are three types of stationary points. The first stationary point, it is called the maximum. The second one, it is called the minimum. And the third one is called the point of inflection. The point of inflection. So in the point of inflection, the gradient of the curve doesn't change. Now, look at this point here. Here we see the curve, it is transitioning from the left to the right of this plane, but the gradient is not changing. Here the gradient at that point, having negative, it is simply negative. But here the gradient, it is positive. This particular point, it is negative. Here the gradient, it is negative, here it is positive. So this point and that point cannot be the points of inflection. But here, it is the point of inflection. So we are going to get the second derivative of our curve, and where there is x, we put there 1 and see whether it is still going to give us 0. Let's go on. So we saw that our second derivative is 60 x squared minus 144x plus 84. So this is Roman 2 that d squared y over dx squared, it was giving us 60 x squared. Yeah, just copy, you have it here, minus 144x minus 144x, then plus 84. So we make a substitution that when x is equals to 1, then d squared y over dx squared is equals to 60 into bracket 1 squared minus 144 into bracket 1 plus 84. So at this particular point, you now use your calculator. We have 60 minus 144 plus 84. As you can see from the calculator, the answer is 0. So, since the gradient does not change its sign, it means that that is the point of inflection. So that one brings us to the end of our lesson. I hope that you have been able to enjoy class, and I look forward to meeting you in our next lesson. Enjoy your time.